The Bakhshali Manuscript stands as one of the most significant mathematical texts from ancient India, offering a rare glimpse into the intellectual and scientific achievements of the subcontinent as early as the 3rd or 4th century CE. The Bakhshali Manuscript is a remarkable ancient Indian mathematical document, discovered in 1881 near the village of Bakhshali, which is now located in Pakistan. The manuscript consists of about 70 fragile birch bark leaves, which are covered with mathematical writing. When it was found, it immediately attracted the attention of scholars because it contained a wealth of mathematical rules, examples, and solutions that were far ahead of their time. Radiocarbon dating of the birch bark leaves has placed the manuscript's origin between the 3rd and 4th centuries CE. This makes it possibly the oldest surviving Indian mathematical manuscript that we know of today. Its age and contents make it a crucial piece of evidence for understanding the history and development of mathematics, not just in India, but in the world. The manuscript is a collection of mathematical rules, practical examples, and solutions. Its main focus is on arithmetic and algebra, but it also contains some material on geometry and mensuration, which is the measurement of geometric figures. The problems and examples in the manuscript are not just theoretical, they are practical and related to daily life. For instance, the manuscript includes problems about profit and loss, income and expenditure, interest calculations, and the measurement of areas and volumes. This shows that mathematics was used in ancient India, not just for abstract thinking, but also for solving real-world problems. One of the most impressive features of the Bakhshali manuscript is its inclusion of advanced mathematical concepts for its time. For example, it contains methods for working with fractions and square roots, including accurate approximations. It also explains arithmetic and geometric progressions, which are sequences of numbers where each term is found by adding or multiplying by a fixed number. The manuscript also deals with simple equations, simultaneous equations, where more than one equation must be solved together, and quadratic equations, which involve squares of unknown numbers. Perhaps most remarkably, it even discusses indeterminate equations, equations that have more than one solution or infinitely many solutions. These are considered a precursor to later developments in algebra. One of the most revolutionary aspects of the Bakhshali manuscript is its use of a dot to represent 0 as a placeholder in the positional numeral system. This is the oldest known recorded use of 0 in this way. Before this, there was no clear evidence of 0 being used as a symbol to indicate the absence of a value in a number. The use of 0 as a placeholder is extremely important because it is the foundation of the decimal system, which is central to modern mathematics and computing. Without 0, it would be very difficult to represent large numbers or perform calculations efficiently. The language and script of the Bakhshali manuscript are also interesting. It is written in a variant of Buddhist hybrid Sanskrit using the Sharada script. This reflects the linguistic diversity of ancient India and shows that mathematical knowledge was being recorded and transmitted in different languages and scripts. The structure of the manuscript is systematic and methodical. Each section typically states a mathematical rule, provides an example, gives a solution, and then offers a proof or explanation. This clear and logical approach to presenting mathematical ideas was unusual for Indian texts of the period, and highlights a sophisticated and organized way of teaching and learning mathematics. The historical and global significance of the Bakhshali manuscript cannot be overstated. It demonstrates that Indian mathematicians were using sophisticated methods and notations centuries before similar developments occurred in other parts of the world. The use of 0 as both a placeholder and a concept was a decisive step in the evolution of mathematics. This innovation influenced later scholars such as Brahmagupta, who lived in the 7th century CE and is famous for his work on 0 and negative numbers. The ideas found in the Bakhshali manuscript eventually helped shape mathematical thought not only in India but also in the wider world. The Bakhshali Manuscript is a testament to India's rich scientific tradition and its contributions to the global history of mathematics. It shows that the Indian subcontinent was a center of mathematical innovation long before similar ideas appeared elsewhere. The techniques and notations found in the Bakhshali manuscript predate and likely influenced later Indian mathematicians, including Aryabhata, who was born in 476 CE. Aryabhata further developed the place value system and algebraic methods. Aryabhata is known for his work in astronomy and mathematics, and he built upon the foundation laid by earlier texts like the Bakhshali manuscript. To illustrate the manuscript's content more clearly, here are a few important examples. First, the use of zero as a placeholder. The Bakhshali manuscript uses a dot to indicate zero in numbers. For example, if a number like 205 was written, the dot would show that there is nothing in the tens place. This simple idea is the basis of our modern number system. The concept of zero as a placeholder allows us to write and understand large numbers easily. Solving quadratic equations. The manuscript contains methods for solving quadratic equations, equations where the unknown number is squared. For example, it might ask, find a number such that when you add 5 to its square you get 30. The manuscript gives clear steps to solve such problems, showing advanced algebraic thinking for its time. Practical arithmetic problems. Many examples in the manuscript are related to everyday life, such as dividing profits among partners, calculating interest on loans, or measuring the area of a field. These examples show that mathematics was used to solve real problems faced by merchants, farmers, and traders. Among the many historians and archaeologists who have studied the Bakhshali manuscript, two stand out for their important contributions, GRK and Takao Hayashi. GRK was one of the first scholars to study and publish about the manuscript in the early 20th century. Takao Hayashi, a modern historian of mathematics, has provided detailed translations and analyses that have helped us understand the manuscript's content and significance. In summary, the Bakhshali manuscript is a cornerstone of ancient Indian mathematics. It is notable for its early use of zero, its systematic presentation of mathematical rules, and its advanced problem-solving methods. The manuscript not only reflects the high level of mathematical understanding in ancient India, but also marks a pivotal moment in the global history of mathematics. Its influence can be seen in the work of later Indian mathematicians, and through them, in the development of mathematics around the world. The Bakhshali manuscript reminds us that the history of mathematics is a global story, with important contributions from many cultures. By studying texts like this, we gain a deeper appreciation for the creativity and ingenuity of ancient mathematicians and the lasting impact of their discoveries.